Okay, this is part 2 of Introduction to Indifference Curves. We only have a couple more slides to go. So we left off on this one talking about what the slope of an indifference curve meant and the definition of marginal rate of substitution. So here we have two different indifference curves drawn on the graph, and the question is which one represents a higher level of utility. So I want you to think about that for a second, pause it, come up with a guess, and then we'll talk about the answer. Okay, so in fact, the blue indifference curve represents a higher level of happiness. We can know that by looking at, let's say, this point A and compare it to this point B. I'm just choosing these 2 points at random. At point A and B, you are consuming the same amount of Pop-Tarts at both 20 boxes. You're both points have the same horizontal coordinate of 20. But at point B, you are consuming more Diet Coke. So according to the assumptions that we talked about in the previous video, because more is better, point B must be better than point A because you have the same amount of Pop-Tarts but more Diet Coke. You can also see this if you choose 2 points like this, here and here. At these 2 points, you're consuming the same amount of Diet Coke, but at this point, you have more Pop-Tarts, so that one has to be better. So point B has to be a higher level of happiness or satisfaction than point A. So the blue is better than the red. Okay. Next slide, we're going to talk about just a couple of fundamental rules about indifference curves. So higher indifference curves indicate better happiness. The economics word for happiness is going to be utility. So you get on a graph, the higher up a indifference curve is, the better it is. It represents a higher level of utility. Indifference curves for the same person can't intersect because it violates the more is better and also just some fundamental rules of logic. So if we look at this point where these two indifference curves intersect, that means that I should be equally happy at points B and C. So just using a little basic algebra reasoning, points A and C are both on the blue indifference curve, so that means A should make you equally happy as C. Points A and point B are also on the same indifference curve, the red one. That means that point B should make you equally happy as point A, which means that all three of these points should make you equally happy. But that violates the more is better rule that we talked about on the previous slide, because at point C, I have the same amount of Diet Coke at both points B and point C, but at point C I have more Pop-Tarts, so C should be a better indifference curve, but we have this contradiction here, so indifference curves can never intersect. This can't happen. No. No functions that give us this type of graph for two different indifference curves for the same person can work to represent preferences. Oh, yeah, so here the third one says the rate of change or the slope along an indifference curve always has to be negative. No section of an indifference curve can slope upwards. If you were to think about what that would mean if it were to happen, let's say we had an indifference curve that looked like this. That would mean that this point and this point would make you equally happy because they're on the same indifference curve. But again, that breaks the more is better rule because you are consuming the same amount of Diet Coke at both points, but you have more Pop-Tarts at let's call this point M than you do at point N. So that means that you should be better off at M, but this indifference curve doesn't show that. You can't have any portion of an indifference curve that has an upward slope. So all indifference curves have to, at every point along them, have a negative slope. We will see some cases where at some points the slope is undefined or it's zero, meaning it's vertical or horizontal, but it cannot slope upwards. Okay, so as I mentioned earlier, in economics, we call happiness or satisfaction utility. So indifference curves represent all the bundles of goods that give you the same amount of utility. So an example of a utility function that is pretty popular in economics is something like this. Your utility is a function. So your utility is a function of how many Diet Cokes you drink and how many Pop-Tarts you consume. And specifically, your utility is given by number of Diet Cokes raised to 1/2 times number of Pop-Tarts raised to 1/2. This equation is what gives you the type of indifference curves we were looking at before that have this shape. So this indifference curve, the lower one, indifference curve A, might be a utility level of 5, let's say. And then indifference curve B, since it's higher, this might be a utility level of 8 or something like that. The units that we use to measure utility are not important. Mathematically, we're just modeling happiness compared to the happiness level that you get from consuming one bundle against a different bundle. So the units don't really matter. We're just saying where are you going to be relatively more happy. We're also not saying that in people's minds they have this function that they are actually calculating anytime they're trying to decide how many Diet Cokes and Pop-Tarts to consume. All it's saying is that if we assume that if we use this type of equation to model the way people prefer goods, we actually get predictions that are consistent with what we see in the world. So we're not saying that this is what people are actually thinking in their minds. We're saying that if we model their preferences this way, we predict the way that people behave a lot of the times. Okay, and that's that. The next slide is just the page numbers for explanations and practice problems in the book. So here you go. Yeah, the pen lasted all the way to the end. Don't want to jinx it. Seems like a good time to go out. All right. Thanks so much. Talk to you later.